Have you ever heard of the Pauli exclusion principle? If you've taken a high school chemistry or physics class, the name probably rings a bell. It has that fundamental rule that says no two electrons in an atom can have the same set of quantum numbers. It's the reason why matter is stable. Why different? Elements have unique properties. But who was the man behind this monumental principle? Today, we're diving into the brilliant, bizarre, and often hilarious world of Wolfgang Pauli. Born in Vienna in 1900, Wolfgang Pauli was a child prodigy. I mean, a serious prodigy. By the time he was a teenager, he was already grappling with Einstein's theory of general relativity. While most of us were figuring out high school drama, Pauli was writing scientific papers that left seasoned physicists in awe. He published his first paper at 18, and by 21, he had written a 200-page article on relativity for a German encyclopedia of mathematical sciences. Even Einstein himself was blown away, saying, "No one studying this mature and grandly conceived work could believe that its author is a 21-year-old man." Talk about setting the bar high. Pauli went on to study under Arnold Sommerfeld in Munich, a hub for the brightest minds in theoretical physics. This is where he truly began to flourish, surrounded by other future legends like Werner Heisenberg. It was a golden age for physics, a time when the very foundations of reality were being questioned and rewritten. The old classical physics was crumbling, and the strange new world of quantum mechanics was emerging. It was chaotic, it was confusing, and Pauli was right in the thick of it, acting as the field's sharpest critic and conscience. Heisenberg famously said of him, "Pauli had a very strong critical faculty. He could immediately see the weak points of any theory." This earned him the nickname, the Wrath of God. If you presented a new idea to Pauli, you'd better have your arguments locked down, because he would ruthlessly tear apart any logical inconsistency. He was known for his cutting remarks. If he thought a theory was not just wrong, but not even worth considering, he'd dismiss it with the legendary put-down, "It's not even wrong." Ouch. Imagine spending months on a paper only to have Wolfgang Pauli tell you it is not even wrong. But this critical nature was exactly what physics needed at the time. As scientists plunged into the weirdness of the quantum world, they needed someone to keep them honest, to point out the flaws and push for greater clarity and rigor. Pauli was that person. His demand for logical perfection helped shape quantum mechanics into the robust theory it is today. Now, let's get to his most famous contribution, the Pauli exclusion principle, which he proposed in 1925. At the time, physicists were struggling to explain the structure of atoms and the periodic table of elements. Why did electrons arrange themselves in specific shells around the nucleus? Pauli's breakthrough was to propose a new quantum number for electrons, which we now call spin, and to state his famous principle: no two electrons can occupy the exact same quantum state simultaneously. It was like assigning a unique address to every electron in an atom. This wasn't just some minor tweak. It was a revolutionary idea that brought order to the chaos. It explained why atoms have volume and don't collapse. It laid the foundation for our understanding of chemical bonding, and it was essential for explaining the properties of everything from metals to stars. For this work, Pauli was awarded the Nobel Prize in Physics in 1945. It was a principle so fundamental that it is now considered one of the cornerstones of modern science. But Pauli's genius didn't stop there. In 1930, he tackled another major puzzle, beta decay. In this radioactive process, it looked like energy was just disappearing. violating one of the most sacred laws of physics, the conservation of energy. Many top physicists, including Niels Bohr, were ready to abandon this fundamental law for the quantum world, but not Pauli. He couldn't accept it. In a move he himself called desperate, he proposed a radical solution. He suggested the existence of a new, unseen particle that was carrying away the missing energy. He described it as a tiny neutral particle with almost no mass, which is why it was so hard to detect. He was so hesitant about this wild idea that he didn't publish it formally. Instead, he wrote about it in a now famous letter to his physicist friends, starting it with, "Dear radioactive ladies and gentlemen." He half-jokingly apologized for proposing a particle that cannot be detected. He called his hypothetical particle the neutron. But a few years later, Enrico Fermi would build on the idea, christen it the neutrino, Italian for little neutral one, and develop a comprehensive theory of beta decay. It would take another 26 years before the neutrino was actually detected experimentally, proving Pauli's desperate remedy was once again spot on. Now, beyond the physics, Pauli was a fascinating and complex character. His sharp intellect was paired with a turbulent personal life and a deeply philosophical mind. In the late 1920s and early 1930s, he went through a severe personal crisis following his mother's death and a short-lived, unhappy marriage. He struggled with depression and heavy drinking. Feeling lost, he did something quite unusual for a physicist of his stature. He sought help from the pioneering psychiatrist Carl Jung. This began a remarkable and long-lasting correspondence between two of the 20th century's greatest thinkers. Pauli, the physicist obsessed with the objective world of numbers and laws, and Jung, the psychologist exploring the subjective world of the psyche, archetypes, and dreams. Pauli meticulously documented over 1,000 of his dreams for Jung to analyze. They explored the parallels between the concepts emerging in physics, like complementarity, and psychological concepts like the conscious and unconscious. This collaboration sought to find a unified language that could describe both the physical and the psychic reality, a bridge between mind and matter. It was a deeply personal journey for Pauli that profoundly influenced his later thinking. And then there's the legendary Pauli effect. This was a mysterious and often comical phenomenon where supposedly Pauli's mere presence in a laboratory would cause experimental equipment to malfunction or break. The effect was so well known among his colleagues that physicist Otto Stern reportedly banned Pauli from his lab in Hamburg. Stories abound. An important device in a Göttingen lab inexplicably failed, and the lab head joked that at least Pauli wasn't there. It was later discovered that Pauli's train had made a brief, unscheduled stop at the Göttingen train station at the exact moment of the failure. Was it just a string of coincidences amplified by his reputation? Was it a running gag among physicists? Or was it something stranger? Pauli himself was both amused and intrigued by it. He saw it as a strange manifestation of the connection between the observer and the observed, a theme that haunted both quantum mechanics and his discussions with Jung. It was another layer to the enigma of Wolfgang Pauli, the man for whom the boundaries between the physical and the psychological world seemed unusually thin. Wolfgang Pauli's life was a testament to the power of a critical, uncompromising mind. He was the conscience of physics during its most revolutionary period. He gave us the exclusion principle, which structures our material world, and he dreamed up the neutrino, a particle that unlocked the secrets of the weak nuclear force. He was a brilliant, difficult, and profoundly human scientist who wasn't afraid to confront the deepest questions of existence, whether in a physics equation or in his own dreams. His legacy isn't just in the principles and particles he discovered, but in his relentless pursuit of truth and his courage to challenge even the most established ideas, including his own. He showed us that science is not just about finding answers, but about asking the right, hard questions. Thanks for joining us on this journey into the life of Wolfgang Pauli. If you enjoyed this, be sure to like, subscribe, and hit that notification bell so you don't miss our next dive into the history of science. Let me know in the comments which scientist you'd like to hear about next. See you in the next video.
Subscribe PastMinds.